Hello, my YouTube family. In the previous video, or rather, I say in the first part of the amazing IIT BHU question, Solid Mechanics, midterm examination of 10 marks, we have seen the first part of that amazing question that is regarding the calculation of the stress in the hammer and the hammer handle. Now, in this particular video, we will say particular solution of the part 2 of the same question. And the part 2 says, once the hammer named Mjolnir hits Thanos, the hammerhead remains in the elastic zone while the handle moves to the plastic zone. Find out the strains for the hammerhead and the handle and also calculate that what is the total elongation of the hammer. Combination of the hammer head and the handle has to be taken, and this particular part carries 3 marks out of the total 10 marks. So here I go up with the solution. So before going to the solution, let's have a look on these two figures, that is the hammer dimension and yes, this particular stress versus strain graph. So in the figure of the Mjolnir, you can easily spot the dimensions of the Mjolnir. That is, the length of the hammer head is denoted by small a and the value of small a is 20 inch. Similarly, the length of the hammer handle or the hammer bar is denoted by small b and the value of small b is 15 inch. And we are also provided with modulus of elasticity E is equal to 10 into 10 raised to power 6 psi. Here psi stands for pounds per square inch. That is the unit of stress, and modulus of elasticity and stress are having the same units, so that's why E is also having the unit psi. Now just look at the graph. You can see this is a graph between stress and strain. So on the y-axis we are having the stress, that is denoted by sigma, having the units psi, and on the x-axis we are having the strain, that is denoted by epsilon, which is having no unit because strain is a unitless quantity. So this is the E sigma diagram, or we can say stress strain diagram. So let me point out some points in this particular diagram. So as you can see, the particular part, let's say divide the diagram in two parts. One is OD and second one is DF. So OD is called as the elastic zone and D is the proportionality limit. So D is the point up to which the Hooke's law is valid. In other words, we can say stress is directly proportional to strain and the proportionality limit is referred to as the modulus of elasticity. So we can say that the slope of the graph, that is OD, that will going to give us the modulus of elasticity E. और आप देख सकते हो कि OD के slope को E से denote भी कर रखा है. So they have given us a hint also that E is nothing but the slope of the line OD. Slope कैसे निकालेंगे? E is basically the value of sigma divided by corresponding strain. So from there we can calculate the strain, that is equal to stress divided by modulus of elasticity. So this is the strain calculation for the hammerhead, because it is clearly mentioned that hammerhead remains in the elastic zone. तो अगर hammerhead elastic zone में है तो वहाँ पे deformation arise होगी, but as soon as the load is removed, the deformation will also be removed and it will be restored back to its initial shape or dimensions. तो फॉर अ टाइम बिंग अगर स्ट्रेन कैलकुलेट करेंगे हम लोग ओडी में, सो दैट इज सिंपली द स्ट्रेस डिवाइडेड बाय मॉडुलस ऑफ इलास्टिसिटी ई. And now look at the part DF, that is the second part of the diagram. So it is also mentioned that the hammer handle deforms plastically. So there will be some kind of permanent deformation arising in the handle. So for a time being, the maximum deformation that can arise in the plastic zone, that is denoted by the point F, and corresponding strain is 0.03. So we can read the value of strain from here, that is simply 0.03. And to calculate the elongation, I'll brief one by one. So like said previously, so we are firstly calculating the value of a strain and the elongation in the hammerhead. So क्योंकि क्वेश्चन में मेंशन कर रखा है और ग्राफ से भी क्लियर है कि जो हैमर हेड है दैट इज डिफॉर्मिंग इलास्टिकली. Elastic deformation means that deformation is not permanent. As soon as the loading is removed, the particular hammerhead will come back to its initial position. But अगर loading लग रखी है तो वहाँ पे deformation arise होगा. So we have to calculate that elongation and we have to compute the corresponding strain. So I have drawn separately the part of the diagram in which we are mainly concerned. For this particular hammerhead. So hammerhead क्योंकि elastic deformation show कर रहा है, so you can see that I have drawn this particular part, that is OD, because that is corresponding to the elastic deformation or the elastic one. सो डी इज अ प्रोपोर्शनैलिटी लिमिट एज आई ऑलरेडी सेड, और हमें पता है कि डी पॉइंट ही वो पॉइंट होता है जहाँ तक हुक्स लॉ वैलिड होती है, दैट इज द प्रोपोर्शनैलिटी लिमिट. सो स्ट्रेस इज डायरेक्टली प्रोपोर्शनल टू स्ट्रेन एंड द रेशियो ऑफ स्ट्रेस एंड स्ट्रेन इज referred to as the Young's modulus of elasticity, capital E. So here E is basically equals to 40 divided by corresponding strain, और जो वो corresponding strain है basically हमें वही calculate करना है. So here I go up with the solution. So we are given that E is equal to 10 into 10 raised to power 6 psi. Again guys, psi is pounds force per square inch. It's pounds force per square inch. Again, it's not a SI system, it is basically some other system except SI, that is FPS system. And E is given as E is equal to 10 into 10 raised to power 6 psi. So for sake of calculation, to make it easier, let's convert into KSI. KSI stands for kilo pounds force per square inch. You can already see here, I have written here like it's kilo pounds force per square inch. Okay, so like we say now 1 kilonewton is equal to 1000 newton. So similarly 1 KSI, that is basically equals to 1000 PSI. So 1 PSI will be 10 raised to power minus 3 KSI. So we have multiplied by 10 raised to power minus 3 to convert PSI into KSI. So यहाँ से हमें E की वैल्यू मिल जाएगी 10 into 10 raised to power 3 KSI और 10 raised to 4 KSI. इतना क्लियर है? Now moving further, so sigma is 40 KSI. You can read from the graph as well. Guys, ये KSI है, don't confuse it with PSI. It's KSI. KSI is kilo pounds per force per square inch. So it is basically, we can say that 1000 times of PSI. Okay, so this is KSI. So 40 KSI. अब मैंने E को इसीलिए KSI में कन्वर्ट किया था क्योंकि हमें रेशियो निकालनी है E और सिग्मा की, तो ये KSI विल गेट कैंसल्ड आउट, सो कैलकुलेशन ईज हो जाएगा. ठीक है. सो अगर आपको मैं बेसिकली यहाँ पे नीडेड तो नहीं है, बट इफ़ यू आर वरिंग लाइक हाउ टू कन्वर्ट KSI इनटू मेगा पास्कल और न्यूटन पर mm स्क्वायर, क्योंकि न्यूटन पर mm स्क्वायर जनरल यूनिट होती है जो हम यूज़ करते हैं मैकेनिक्स में. सो वो कन्वर्जन मैंने आपको यहाँ पे करके दिखा रखा है, सो यू कैन हैव अ लुक ऑन दिस. सो 1 KSI is 10 raised to power 3 PSI. Firstly, we will convert pounds into kg. So 1 pound is 0.4535 kg. Now we will convert kg into force. So we have multiplied by 9.81. So ऊपर की वैल्यू न्यूटन में आ गई. Square inch means inch का square. So 1 inch is 2.54 centimeter. So it is 2.54 into 2.54 और 1 centimeter square is 100 millimeter square. So we have multiplied by 100, तो ये नीचे की वैल्यू मिलीमीटर स्क्वायर में आ गई. सो इसको जब सॉल्व करेंगे तो फाइनल वैल्यू वी विल गेट इन न्यूटन पर mm स्क्वायर, एंड यू वेल नो दैट 1 मेगा पास्कल इज नथिंग बट 1 न्यूटन पर mm स्क्वायर. सो 1 KSI की जो वैल्यू होती है दैट इज 6.8957 मेगा पास्कल. इस क्वेश्चन में देयर इज नो नीड टू कन्वर्ट, अगेन आई एम रिपीटिंग, देयर इज नो नीड टू कन्वर्ट, जस्ट टू tell you guys that how to carry the conversion of KSI into Newton per mm square, because some bad day or some good day you might face this conversion, somebody may ask you as well, so आपको आना चाहिए. That's why I am saying this. So this is not a part of the solution, this is extra. Okay, because solution में तो KSI में ही converted है units, तो वहाँ पे cancel हो जा रही है. Moving ahead, so like we can say that जो मैंने अभी बोला वर्बली, उसको मैंने यहाँ पे नोट भी कर रखा है कि सिंस सिग्मा एंड ई आर हैविंग द सेम यूनिट्स KSI, सो देयर इज नो नीड टू कन्वर्ट देम इनटू मेगा पास्कल्स बिकॉज इट विल मेक द कैलकुलेशन लेबोरियस एंड इट विल बी टाइम टेकिंग, सो नो नीड टू डू दैट एट ऑल. So as per Hooke's law, we know that stress is E times of strain. So strain is sigma upon E. The value of E we have already calculated. That is, you can say 10 into 10 raised to power 3 KSI, and sigma is 40 KSI. So it's 40 upon 10 into 10 raised to power 3. So let's use my calci and calculate this particular value. So it's 40 divided by 10 divided by 10 raised to power 3. So you can see the value of strain is coming out to be 0.004. So let's note down this particular value. It is 0.004, or you can call it as 4 into 10 raised to power minus 3. So this is the basic value of strain that is arising in the hammer handle. Moving ahead, now we have to calculate the elongation also, because in the same question they have asked the elongation in both the hammerhead and in the hammer handle. So elongation क्या होता है? Strain का formula क्या होता है? Strain is a unitless quantity having a formula that is change in dimension upon original dimension, that is delta L upon capital L. हमें डेल्टा एल ही कैलकुलेट करना है. सो डेल्टा एल इज बेसिकली एल टाइम्स ऑफ द स्ट्रेन. सो स्ट्रेन इज ई एल एप्सिलॉन एल. सो एप्सिलॉन इज डेल्टा एल बाई एल, क्योंकि इसलिए यहाँ से ये चीज़ें आ गई. अब नाउ वी हैव टू कंप्यूट डेल्टा एल. So what is the value of epsilon? That is basically 0.004. See, 0.004. So this is 0.004. A is basically यहाँ पे जो लेंथ हमें लेनी है, क्योंकि हम हैमर हेड कैलकुलेट कर रहे हैं, उसके लिए इलोंगेशन निकालना है, तो वी हैव टू टेक द लेंथ ऑफ द हैमर हेड ओनली, एंड द लेंथ ऑफ द हैमर हेड यू कैन सी इन द डायग्राम. That is, you can see it's A is basically 20 inch. So 0.004 into 20. So you will multiply this 0.004 into 20. So देखो 0.08. So you are getting the value of elongation as 0.08. यूनिट्स क्या होगी गाइस? इंच होगी, क्योंकि हमने यहाँ पे ए की वैल्यू इंच में ले रखी है. सो इफ यू वांट टू कन्वर्ट दिस इंच इनटू सेंटीमीटर, सो इट विल बी 0.08 into 2.54. So it is 0.2032 centimeters converted into millimeters. So it is 2.032. So 2.032 millimeters. So this much elongation we are getting in the hammerhead. Either you can report in inches, 0.08 inch or 2.032 centimeters. So hope you are all clear with this, and now moving on to the second part of the same question, because ये तो हमारा हो गया calculation किसके लिए? hammer head के लिए. We have to compute the same thing, the same manner we have to go for the hammer handle also, but there is a difference that in hammer handle the deformation is not elastic at all, it is a plastic deformation. So calculation will be a bit different, but the process will be same. I think that will going to be easy as well. So let's go. So for the hammer handle, in the graph you can see that we are having this second region, that is basically the DF region. So that is denoting the plastic deformation. So we'll read the from the graph itself, we will read the value of this strain corresponding to the point F. So that ultimate strain is it's 0.03. graph se aap dekh sakte ho, that is 0.03. So we'll read this particular value. So this is the strain in the hammer handle in the plastic region. And now we know that that strain is obviously elongation divided by original dimension, और basically यहाँ पे जो हम dimension लेंगे ना, that is going to be the length of the hammer handle. So that is denoted by small b, and the value of a small b is 15 inches. So delta L elongation is basically epsilon times b. So it is 0.03 into 15. So if you calculate this 0.03 into 15, it is basically 0.45. So it's 0.45 inches. So we can say that 0.45 inch is basically, we can say that elongation in the hammer handle. You can convert it into millimeters also. So it is into 10, 11.43. So you can see in the plastic and deformation is coming out to be a bit more. It is basically 11.43 millimeter. Question is not over yet. They are asking us the total elongation, that is the combination of the hammerhead and the hammer handle. So that is simply equals to the sum of the individual elongations. So for hammerhead we have got the elongation as 0.08 inch, and for the hammer handle we have got it as 11.43 millimeters or 0.45 inch. So we will add both the values. So 0.08 plus 0.45, that is 0.53 inch, that is equivalent to 13.462 millimeter. So here we are completely done with the part 2 of this amazing question that is asked in IIT BHU. So we are done with both the things that is asked in the part 2 of this question that carries 3 marks. So almost we are done with the 2 marks in the first part and 3 marks in the second part. So 50% is completed. For the next 2 parts, stay tuned. I'll show the solution in the next upcoming videos. Takes a lot of effort to prepare the solution, searching the question and what the content should be delivered. So please, if you are watching it, if you are liking it, please do subscribe and do share and hit the bell icon as well. And bye bye. Stay tuned for the next parts in the next upcoming videos. Bye bye.